answer some questions about polygons. This first question right here, this first set of questions I should say, is asking if each of these figures is a polygon, but if it's not a polygon, you have to say why not. For number 1 here, I'm going to say this is not a polygon, and if we look at our definition of a polygon, it says that polygons have to only be made up of line segments, that each line segment intersects with exactly 2 others, and that the line segments only intersect at endpoints. Well, for these line segments over here, this one and this one, it intersects with 1, 2, 3 points. So it does not follow number 2. It should only be intersecting exactly 2 lines, and this time it's intersecting 1, 2, 3. On top of that, it's not following rule number 3 of our definition. The line segments can only intersect at endpoints. Well, this intersection right here is not at an endpoint. So that's why this is not a polygon. Number 3 here, yep, it is a polygon. It's made up of line segments. They only intersect at 2 points. And to top it all off, they only intersect at endpoints. So this is a polygon. Try to answer the rest of them on your own. The next part is to try to name polygons by using the descriptive things that we have about polygons. So, for example, I'm going to talk about if it is convex or concave, regular or irregular, and then how many sides it has. Those are the 3 things I can talk about when I'm talking about a polygon. Let's take a look at number 1 as an example. Well, is this convex or concave? There's no caves going into my shape, so this is convex. It looks like every side here and every angle is the same, so I'm going to say that it's regular. And this final part is I need to count how many sides it is. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides, so I can call it a 12gon. So it is a convex, regular 12gon. If we take a look at number 2, this has caves going inside of it. These are points that are going inside the shape. So this is concave. These side lengths are all different, and the angles inside here are not all the same. So that means it is irregular. And then how many sides? Well, it's 1, 2, 3. Let me go around clockwise. 1, 2, 3, 4, 5, 6, 7, 8. So it is an 8gon or a concave irregular 8gon. Or instead of saying 8gon, I could say, let me make sure, 1, 2, 3, 4, 5, 6, 7, 8. I could call it a concave irregular octagon. Now take a moment and try to answer questions 3 and 4 on your own. All right, these questions are starting to get a little bit more difficult. Let's take a look at number 1 together, and then you have to try and think on your own. If I have a triangle that has vertices R, S, and T, I want you to list all of the names of that triangle. So let's use the triangle up here. I'll give R, S, and T as the vertices. The only thing I need to remember about the names is that I start with any point and I just trace out my shape. So R, S, T, that is one name for my polygon or my triangle. I could even do RTS. That's another okay name. How many names are there going to be for this triangle? And list them all out. Number 2 is asking if a valid name of a pentagon is A, B, C, D, E. For each below, you have to say whether or not it's also a valid name. Well, the best way to do this is to draw out a polygon whose name is A, B, C, D, E, and then you can check those other names. So I'll draw out, let's see, it's going to have 1, 2, 3, 4, 5 vertices. 1, 2, 3, 4, 5. A, B, C, D, E, and I'll just trace that out. A, B, C, D, E, A to B, C, D, E, and then close it off back to A. Now I can check these other names to see if they work out. If I end up drawing a diagonal here when I'm tracing the name out, it's not good. how many different names can a three-gon have? Well, we just did that. A triangle is a three-gon, so if you listed all those names out, you should be able to say how many names you got. Now, think about, or maybe draw out and list out all the names. How about for a four-gon or a five-gon? And then how much would it be if it was the number n? That means any number. It's going to be, well, try and figure it out. Backside of this, it is asking us to draw and illustrate these things. So I have a regular pentagon. Well, a pentagon means that is a five-gon. It has five sides. Try to draw it out, and then when you get the points, you have to give me the name, a valid name for it. Same thing for each of these. Finally, we're going to do some thinking. This paragraph describes here innies and outies. Innie points are just points that are making our polygon become concave. Or you can think of it as a point such that if I drew a line and I kept going through that vertex, I'd end up on the inside of my shape. So this is an innie, this point right here, but this point right here is not an innie because if I continued a line from either side, I end up outside of the shape. And it wants us to label all the innies and outies. Well, this is on the outside, this is an innie. Let's see. This is an outie because if I try to draw a line going past it, that one is an outie. This one right here is an innie. I've got an outie here, an innie here, and an outie here. Next, it asks some questions about, do you think we could have a polygon that has only innies? Try drawing it, see if that's possible. And then, what would be the greatest number of innies that a four-gon can have, or what about a five-gon? Can you explain the pattern that you're starting to have?